Or ever wondered what comparative analysis is and how it's used in data science? Well, you're about to find out. Comparative analysis, in simple terms, is an investigative technique that data scientists use to make sense of the world. It's like a detective's magnifying glass, helping us to zoom in on the minute details hidden within vast seas of data. Picture this. You have two different data sets, each one a treasure trove of information. What comparative analysis allows you to do is dive into these data sets, identify patterns, and then compare these patterns across the two data sets. It's about looking at the similarities, the differences, the anomalies, and the consistencies. Every pattern, every piece of data, is a clue that brings us closer to understanding the bigger picture. In essence, comparative analysis is about finding patterns and drawing conclusions from different sets of data. So why should you care about comparative analysis? Well, for starters, it's essential for data-driven decision-making. Comparative analysis is like the backbone of data science. It allows us to compare, contrast, and decipher the meaning behind vast amounts of data. But why is it so important, you might ask? The answer is simple. It's all about making informed decisions. Imagine you're a business owner. You have two products, and you want to know which one is more popular among your customers. Without comparative analysis, you might have to rely on gut feelings or anecdotal evidence, which can often lead to inaccurate conclusions. However, by comparing the sales data of these two products, you can get a clear picture of which product is the front runner. This allows you to make data-driven decisions about where to focus your marketing efforts. But comparative analysis isn't just useful for decision-making. It's also a powerful tool for problem-solving. Say you've noticed a sudden drop in your website's traffic. By comparing the data from before and after the drop, you can identify any changes that might have caused this issue. Did a specific web page become less popular? Did visitors start spending less time on your site? Comparative analysis can help you answer these questions and find a solution. Furthermore, comparative analysis plays a crucial role in predictive modeling, another vital aspect of data science. Predictive models use historical data to predict future outcomes. By comparing data from different periods, these models can identify patterns and trends that can inform future predictions. For example, if a certain product's sales have been increasing every quarter for the past 2 years, a predictive model might predict that this trend will continue in the future. So, there you have it. Whether it's making data-driven decisions, solving problems, or building predictive models, comparative analysis is a fundamental tool in the data scientist's toolbox. It allows us to sift through massive amounts of data and find the nuggets of information that can drive success. Without comparative analysis, making sense of large volumes of data and drawing meaningful conclusions would be significantly more challenging. Now that we understand what comparative analysis is and why it's important, how exactly is it applied in data science? In the world of data science, comparative analysis serves as a powerful tool to decipher complex data landscapes. It brings clarity to the chaos, allowing data scientists to draw meaningful insights that can drive decision-making processes in organizations. At the heart of comparative analysis in data science is the process of data collection. This involves gathering relevant data from various sources. Data scientists may collect data from databases, surveys, social media, or even from web scraping. The key here is to gather a comprehensive set of data that provides a rich context for the analysis. Once the data is collected, the next step is data cleaning, also known as data pre-processing. This stage involves removing any inconsistencies, inaccuracies, or redundancies in the data. Data scientists might also need to deal with missing values and outliers in the data. This step is crucial because the quality of the data directly impacts the accuracy of the analysis. As the saying goes, garbage in, garbage out. With the data cleaned and pre-processed, it's time to dive into the actual comparative analysis. This is where data scientists apply statistical methods to compare and analyze the cleaned data. They might use techniques such as t-tests, chi-square tests, or ANOVA, analysis of variance, depending on the nature of the data and the specific questions they're trying to answer. For instance, a data scientist might use a t-test to compare the average income of two different demographic groups, or a chi-square test to see if there's a significant association between two categorical variables such as gender and preference for a particular product. ANOVA, on the other hand, might be used when comparing the means of more than two groups. It's important to note, however, that comparative analysis is not just about crunching numbers. It also involves interpreting the results and drawing meaningful conclusions. It's about understanding the story that the data is telling and using that understanding to inform decisions. Data scientists might also use visualizations to help interpret the results of a comparative analysis. Graphs, charts, and plots can help to convey complex statistical results in a way that's easy to understand. This can be particularly helpful when presenting the results to stakeholders who may not have a deep understanding of statistical methods. In essence, comparative analysis in data science is a multi-step process that involves collecting data, cleaning it, using statistical methods to compare and analyze it, and then interpreting the results. Each step is crucial and requires a combination of technical skills and critical thinking. Comparative analysis provides data scientists with a powerful tool to make sense of complex data landscapes. And as we move into an increasingly data-driven world, the ability to effectively conduct and interpret comparative analysis will only become more important. It's always helpful to see theory in action. So consider this common example of comparative analysis in data science. Picture this. A retail company wants to compare the shopping behavior of two different demographic groups, let's say millennials and baby boomers, to tailor their marketing strategies effectively. The company has collected data from its customers over a year. This data includes age, gender, purchase frequency, average spend, and product preferences. The data science team is tasked with the challenge of extracting meaningful information from this data. Now, using comparative analysis, the team sets out to find patterns and differences in the shopping behavior of these two demographic groups. They start by comparing key metrics like purchase frequency and average spend. Let's say they find that millennials purchase more frequently, but baby boomers tend to spend more per transaction. Next, they compare product preferences. Perhaps they discover that millennials are more inclined towards eco-friendly products, while baby boomers prefer traditional, well-established brands. This kind of insight can help the company tailor its product offering and marketing messages for each group. The team doesn't stop there. They further delve into the data to find subtler patterns. For instance, they might find that baby boomers are more likely to shop in the morning, while millennials tend to shop late in the evening. This information can guide the company's decisions about store operating hours or timing of online promotions. The team's findings are then presented to the marketing department, providing them with actionable insights to refine their strategies. Perhaps they decide to launch an eco-friendly product line to attract more millennials, or schedule morning promotions to cater to the baby boomer shoppers. This case study shows how comparative analysis can uncover insights that would otherwise remain hidden in your data. It's a powerful tool that can help businesses understand their audience better, make informed decisions, and ultimately drive growth. So the next time you're faced with a heap of data, remember the power of comparative analysis and let the data tell its story. So what should you remember about comparative analysis in data science? Well, let's recap the key points we've discussed. Comparative analysis at its core is a methodology that allows you to compare two or more data sets to uncover relationships and patterns. It's like a magnifying glass for data, amplifying the subtle yet significant differences and similarities that may not be immediately apparent. Remember, in the world of data science, comparative analysis is not just important, it's indispensable. It's the backbone of any data-driven decision-making process. It helps you to identify trends, spot anomalies, and ultimately make more informed decisions. Whether you're analyzing customer behavior, studying climate change, or predicting stock market trends, comparative analysis serves as your guiding light, illuminating the path towards insightful conclusions. Comparative analysis in data science isn't just about crunching numbers, though. It's about asking the right questions, setting up the right hypotheses, and then using the power of data to test these hypotheses. It's about being curious, being investigative, and being willing to dive deep into the data to uncover the truth. And remember, comparative analysis isn't a one-size-fits-all approach. It's a flexible tool that can be tailored to suit your specific needs. Whether you're comparing data over time, across groups, or between variables, comparative analysis can be adapted and applied in a myriad of ways. In data science, comparative analysis is often coupled with machine learning algorithms and statistical models. This symbiotic relationship enhances the power of comparative analysis, allowing you to not just understand the past and present, but also to predict the future. So, what's the bottom line here? Comparative analysis is a powerful tool in the data science toolbox. It's a method that allows you to sift through large amounts of data, uncover hidden patterns, and draw meaningful conclusions. It's a means to an end, with the end being a deeper understanding of the world around us. Remember, comparative analysis is a crucial tool in your data science toolkit. It helps you make sense of large data sets and draw meaningful conclusions.